Good evening, dear students. Today I am going to discuss about the alkalinity of the water sample. So in the alkalinity of the water sample, first of all, how many types of alkalinity of water samples are there, and what is the importance of alkalinity of water is there, what is the range of alkalinity of water, that can be discussed now. So anyhow, water generally we are using for the three purposes. One is the domestic purpose, next irrigation purpose, and another one is the industrial purpose. Generally water we are using. So water is very important in our life. So and water quality is also very important. So in the water quality parameters, generally broadly we are classifying into three types. Those are here. First one is the physical parameters, another one is the chemical parameters, and biological parameters. Thus the water quality parameters broadly we are classifying into three types. So you know very well, whenever a water sample is given, one glass of water is given to you, directly do you drink? You never drink directly. What happening? First what you do? Generally you look into the water. So either the water is clear solution or not, that you see first of all. If the water is very clear, that means the turbidity is not there, and then the water just you do the taste, just to you water glass, just to you try to drink it and you do the taste. So when you see the taste, if it is good, then only you go for the further drinking. Sometimes if unknown person is given to you, you will see the smell also. Generally if smell is not good, if any bad smell is coming, you never drink that water sample. This is about the physical parameters. Generally everybody very well, everybody are experienced in our life generally. So after physical parameters, then okay, the quality physical parameters all are very good. That means no color and taste is also good, and no turbidity, everything is good. So then what shall you do? Okay, you are drinking the water sample, and after sometimes what happening, some health issues are coming and some health problems are coming. So whenever the health problems are coming, what shall you do? Generally, okay, one water sample will be given to the chemist person and analyze this water sample, and then you give us and what is the water quality parameters, and then is it reaches to the WHO guidelines or not. Everything will be discussed. Generally we are doing it in our daily life. So anyhow, if the water some health issues are coming, generally you will go for the chemistry analysis, and then you analyze the water sample. So what are the quality parameters they will study? So generally when coming to the water quality parameters point of view, first one is the physical parameters. Everybody we know that physical parameters, everybody we know that physical parameters. Second one is the chemical parameters we will study, and next one is the biological parameters also we will study. Suppose if the physical parameters, if it is good, then okay, no problem, then you go for some, even though you drink some health issues are coming, then you go for the chemical parameters study. So when you come into the chemical parameters point of view, generally the water quality parameters, either the pH is where is it within the limit or not. The generally pH limit, generally 7 to 8 pH can be, you can drink for the water. So pH 7, so 7 to 8 can be. And if you come into the pH, if it is good, then you go for the hardness. Water one of this is also one of the water quality parameters. And hardness is also within the limit, like below 200 ppm if it is present, then if it is below 200 ppm, then hardness is also good. Then alkalinity is also one of the water quality parameters, which we are going to study about the alkalinity now. Alkalinity, that is also one of the water quality parameters. So alkalinity generally 20 to 200 mg per liter, that is ppm, otherwise you can call it as. So that is also, if it is within the limit, then okay, alkalinity is also good. Then you go for the DO. Generally DO point of a dissolved oxygen, whenever the any microorganisms are present in the water sample, generally the DO levels are decreasing. Any green algae are present in the water sample, generally the dissolved oxygen levels will be increases. Optimum dissolved oxygen generally 8 ppm will be present in the normal water sample. Within the limit, if it is present, okay, well and good. Otherwise, generally treatment is required for this water sample. Next, if DO is good, next BOD and COD also, generally all these are coming under the chemical parameters. So if it is within the limits of all chemical parameters, okay, well and good, even though some illness are there, then you go for the biological parameters. Generally biological parameters are nothing but any bacteria or virus may be contaminated the water sample, that will be studied. So that is called as the biological parameters. So this is about the importance of the alkalinity and water quality parameters especially. So now the alkalinity is one of the water quality parameters. So very important thing is how the alkalinity, how can you estimate, and what is alkalinity? First definition you see, acid neutralizing capacity of the water. Acid neutralizing capacity. Acid neutralizing capacity of the water acid neutralizing capacity of the water is called as alkalinity. Generally the definition, acid neutralizing capacity of the water is called as alkalinity. This is about the alkalinity. So acid basicity, nothing but alkalinity is also, otherwise it can be called as basicity also. So generally, what are the ions caused per alkalinity? So here 3 ions are caused per alkalinity, that is OH minus 1, OH minus, CO3 minus 2 and HCO3 minus. Here hydroxyl ions, carbonate ions, bicarbonate ions, these are the 3 ions caused per alkalinity. So out of these 3 ions, the alkalinity may be caused by only hydroxyl ions or only carbonate ions or only bicarbonate ions. These may be individual ions may be caused, or combination of the ions may be caused by the alkalinity. Like hydroxyl carbonate may be there, and hydroxyl and the bicarbonate and carbonate may be caused by the alkalinity. This is the combinations. Anyhow, another combination which we are thinking about, the bicarbonate and hydroxyl combination is not possible, because if it is there, immediately they will react together to give the water and carbonate. This is the acid base reaction takes place. So this combination is not available. So only hydroxyl carbonate may be present or bicarbonate carbonate may be present in the combinations generally. So generally the phenolphthalein, here totally the alkalinity can be classified into 2 types. One is the phenolphthalein alkalinity and another one is the methyl orange alkalinity. Here 2 types of alkalinities are there. So if you see the alkalinity, methyl orange alkalinity and phenolphthalein alkalinity, these 2 types of alkalinities are there. So based upon the indicator phenolphthalein alkalinity as well as methyl orange alkalinity, those 2 types of alkalinities are there. So now what about the phenolphthalein alkalinity? What about the methyl orange alkalinity? What ions can be estimated by using phenolphthalein indicator? What ions can be estimated by using methyl orange indicator? That we should understand first of all. So phenolphthalein indicator pH range is the, generally phenolphthalein indicator, the range 8.3 above 8.3 above, it will exhibit the pink color generally. Below 8.3 it will exhibit the colorless. So the hydroxyl ions and carbonate ions, these 2 ions generally pH is greater than 8.3, and bicarbonates where the pH is less than 8.3. So by using phenolphthalein alkalinity or phenolphthalein indicator, only these 2 ions can be estimated. So anyhow, in this estimation, what is the reactions are taking place? Here generally the hydroxyl will react with the 1 mole of H plus ion to give the H2O. This is the neutralization reaction. And carbonate ion react with 1 mole of H plus ions to give the HCO 3 minus. This is the carbonates are converting into bicarbonates. Whenever it is converting into bicarbonates pH is less than 8.3, so colorless it will get. So end point will be completed up to this reaction only. So the bicarbonates, only half of the reaction is completed in this reaction. In this equation we can understand that too. Only with the phenol indicator these two reactions only we can complete. So remaining reaction, if it the bicarbonates generally reacting with 1 mole of H plus ion, another mole of H plus ion to give the H2CO3. This is the reaction generally we are expecting. So generally this can be written as the carbon dioxide plus water, also the same reaction we can represent. This is also correct representation only. This is the carboxylic acid, this is the carbonic acid, this is called as, and this is the carbon dioxide plus water, same. That is, whenever the carbon dioxide dissolves in the water, it will give the carbonic acid, the same one is there. So this is about the phenolphthalein indicator. So whenever you coming to the this reaction where we cannot complete with the phenolphthalein indicator, so then methyl orange indicator will be used. When you see the methyl orange indicator, generally the methyl orange indicator pH whenever the above 4, the pH above 4, generally it will exhibit the yellow color. Above 4 mean up to 7, 4 to 7 is also acidic, but even though acidic, above pH 4 is, it will exhibit the yellow color, and below 4 generally it will exhibit the red color or pink color. Generally we are pink color also we can call it as, a red color we can exhibit. So this is about the methyl orange indicator range. So whereas by using methyl orange indicator, the total alkalinity can be estimated. By using methyl orange indicator, the total all the 3 ions can be estimated. Hydroxyl ions, carbonate ions and bicarbonates, all the 3 ions can be estimated by using methyl orange alkalinity. Methyl orange alkalinity otherwise called as the total alkalinity also. By using phenolphthalein alkalinity, here we can estimate the only hydroxyl and half of the carbonates only we can estimate by using this. And here you can see this. Why you are using 2 indicators? Generally when you use the 2 indicators where the ions carbonate, bicarbonate and hydroxyl ions are these are different anions, gives the end point at different pH values. That is the reason why we are using the 2 indicators to estimate all the 3 ions, and the individual ions also can be estimated by using this these 2 indicators. By using these 2 indicators we can estimate total, right? So now if you see, whenever how can you procedure, you see the procedure, how can you estimate the experiment procedure? If you see in the, so a water sample will generally, generally 2 steps will be there in any volumetric analysis. First one is the standardization step, another one is the estimation step will be there actually. So in the standardization process, generally we are estimating we are standardizing the HCl solution constant, because of HCl is the secondary standard solution, sodium bicarbonate is the primary standard solution. We know that by using sodium carbonate, which is the primary standard solution, generally we are standardizing the HCl solution, right? And then after standardization we go for the second step for the estimation of the alkalinity of the water sample. Generally we are doing that. Okay, so now in this procedure, here if you see, this is the burette, where in the burette generally we are taking the HCl solution, where 0.02 normal HCl solution generally we are taking in the estimation of alkalinity of the water sample, and the analyte, otherwise called as the water sample, we are taking into this conical flask. So now what happening, first for the water sample we are taking the water sample and we are adding the phenolphthalein indicator. Suppose if you imagine that if only hydroxyl ions are present, what will happen? The total hydroxyl ions can react with the phenolphthalein indicator. In presence of phenolphthalein indicator, total ions can react. In the volumetric analysis, you must understand one principle. First, at the beginning, the water sample is having only alkalinity, that is only it is basic in nature. So whenever the water sample is completely neutralized, whenever you add one more drop of the HCl solution where your water sample is converting into basic into the acidic. So whenever it is converting into basic into acidic, see the pH is drastically decreases. Then the 7 we know very well, that is, or 3 or 4 it will, because of strong acid we are using, so the pH will be below 3 or 4 also can be there. So that is the reason why where immediately phenolphthalein indicator, because of less than 8.3 it is colorless, it is exhibiting. At the beginning pink color when you add phenolphthalein indicator, and whenever the solution turns to that basic into acidic, colorless you are observing. So like this the hydroxyls we can estimate by using this only hydroxyls we can estimate, for example. Next, only if carbonates are present. If carbonates are present, what happening? Only 1 mole of H plus ions react to give the HCO3 minus, which is the first step in the carbonates. 2 steps are there in to estimation of the carbonates. Only if I use the phenolphthalein indicator, if I use first beginning, pink color is there because of the phenolphthalein indicator in basic medium, it will exhibit the pink color, acidic medium colorless. So whenever the carbonates, the in presence of phenolphthalein indicator, they will exhibit the pink color, and the water sample is estimated against the HCl which is filled in the burette. So then what happening? The first step will be completed. So whenever this step is completed, you will get the colorless. So to this colorless solution, so you need to add 1 or 2 drops of methyl orange indicator, and then you need to continue this titration. So when you use the here phenolphthalein indicator is completed, reaction is completed, then methyl orange indicator will be added. When you add methyl orange indicator, where the methyl orange indicator in a base medium, it will exhibit the yellow color or orange color it is exhibiting. So whenever the total bicarbonates react with the another mole of H plus ion to give the CO2 plus H2O reaction takes place generally. So whenever reaction is completed, whenever the basicity is not there in the conical flask, then the solution turns to acidic nature. So whenever it is acidic nature, in presence of methyl orange indicator, then acidic medium, generally red or pink color, you will get the end point. So like this you will get the end point. So this is about the carbonate ions. Suppose if bicarbonates are present, the bicarbonates are present in our water sample, where phenolphthalein if we add, only directly colorless you will get, because of in presence of bicarbonate where the pH is less than 8.3, so it will give the colorless with the phenolphthalein indicator. So we cannot estimate the bicarbonates by using the phenolphthalein indicator, right? So now phenolphthalein indicator we cannot estimate. That is the reason why we need to add the methyl orange indicator only whenever the bicarbonates are present in our water sample. So now here bicarbonates, when you add methyl orange indicator, you will get the yellow color. So after neutralization, colorless you will get. So thus you can estimate the bicarbonates only by using methyl orange indicator. If you switch the relations, whenever phenolphthalein alkalinity is 0, it indicates that the bicarbonates are present, that is equal to the methyl orange indicator only. So whenever the P equal to methyl orange alkalinity, then it is hydroxyl ions are present. When the phenolphthalein alkalinity is equal to the half of the methyl orange alkalinity, then carbonates may be present in the water sample. So like this we can, whenever the P is less than half m, then whenever the P is less than half m, when P is less than half m, whenever the carbonates and bicarbonates are present, where with the phenol indicator only carbonates, half of the carbonates can be reacted and remaining bicarbonates cannot be reacting with the phenol indicator. That is the reason why generally P is less than half m it will be there, because carbonate is P equal to half. That means carbonate, only carbonate is there, P equal to half m. So bicarbonate is there, then what happening? The P is less than half m, it will happen. So HCO3 minus and CO3 minus 2. These two ions, whenever it is present, P is less than half m, relation will come. So if the P is greater than half m, when it is possible, if hydroxyl ions are present, total hydroxyl ions can be reacting by using phenol indicator, and if carbonates are present, half of the carbonates can be reacting with the phenol indicator. So whenever the hydroxyl and carbonate ions are present, P is greater than half m will be there. This is the relation where we can estimate. So now if you see the here, if you see the relation, if P equal to 0, then only bicarbonates are present, that is equal to methyl orange alkalinity only. If P equal to m, only hydroxyls are present, so it is equal to the phenolphthalein alkalinity only. So these two are absent. So, and if P equal to half m, then whenever carbonate ions are present, so that is equal to the 2p, because of P equal to half m, then whenever 2p it is equal to, when P is less than half m, whenever the P is less than half m, then carbonate bicarbonates will be present. So carbonates, whenever the P equal to half m, that carbonates and bicarbonates are present, for example, by using phenolphthalein indicator, only half of the carbonates will be completed. That means the phenolphthalein indicator is equal to the half of the carbonates. So to give the complete carbonates, 2p, that is, and whenever the bicarbonates, the remaining amount of bicarbonates, so carbonates are completed, so m is the total alkalinity, so m minus 2p will give the bicarbonates value. When P is less than half m, when P is less than half m, then hydroxyl and carbonates are present. Hydroxyls, so total hydroxyls can be estimated by using phenolphthalein indicator, and the remaining carbonates, half of the carbonates only can be half of the carbonates only will be reacting by using methyl orange indicator. Here by using phenolphthalein indicator, complete hydroxyls and half of the carbonates will be reacted. Remaining half of the carbonates, whenever you add the methyl orange indicator, that will be reacted. That means m minus p will give the half of the carbonates. Then 2 into m minus p will give the complete carbonates. When you know the amount of the carbonates, how can you know the hydroxyls? m minus 2 into m minus p. So thus m minus 2m minus 2p. Thus m plus m minus m. 1m will be cut. So 2p minus, so plus minus of minus plus. So 2p minus m, it will give the hydroxyl. So 2p minus m, it will give the hydroxyl ions. So thus we can estimate the hydroxyl ions by using this formula also. This is the table you can. So problems we will do first. When we see the problems, Here a water sample is given. The water sample is alkaline nature, phenolphthalein alkalinity, methyl alkalinity is there. So 100 ml of the water sample is given to you, and it requires the 12 ml of the acid to reach the phenolphthalein alkalinity, and for the same sample 4 drops of the methyl is added, and then this titration is completed. Then after addition of the 4 ml, another 4 ml, then you will get the end point. Another 4 ml means here total alkalinity, methyl orange alkalinity is nothing but total alkalinity. 12 plus 4, that is 16 ml is required for the completion of the methyl orange alkalinity. That means, so now we can calculate very easily by using the stoichiometric equation first of all. You know that N1 V1 equal to N2 V2 principle you can use very easily, you can estimate it. So then just you can imagine this is the water sample and this is the HCl solution you can. So normal of the water sample, just you don't know that, you need to find out that, you can think V1 is the water sample volume, how much it is taken, 100 ml you are taken, and normal of the HCl solution, how much it is, 1 by 50 means 0.02 normal, that is 0.02 normal, and volume of the HCl solution is the, for the phenolphthalein alkalinity, first 12 ml it is, that will be calculated. So N1 equal to 0.02 into 12 divided by 100. So always we must calculate the normality up to 4 digits without fail, then only it is correct, otherwise this value will come wrong. So then you are getting the 0.0024 N you are getting. So for the calculation of alkalinity, equal to normality into calcium carbonate equivalent weights. This will give the gram per liter. When you multiply the 1000, then it will give ppm. So normality you calculated here 0.0024 and into 50 into calcium carbonate equivalent weight 50 into 1000. Then it will give so this will give the 120 ppm phenolphthalein alkalinity. This is P alkalinity. Next, when you go for the methyl alkalinity, so same N1 V1 equal to N2 V2 principle. So here you can imagine this is the water sample, this is the HCl solution. Then normality of the water sample need to find out here also. Volume of the water sample 100 ml we are taken. Normality of the HCl solution, if we take 0.02 only here also. Volume of the HCl required 12 plus 4 16 ml. So then N1 equal to 0.02 into 16 by 100. That will give the 0.0032 N. So alkalinity, methyl alkalinity equal to 0.0032 into 50 into 1000. So it will give the 160 ppm. So then methyl orange alkalinity 160 ppm. If you see the relation 120 160, here P alkalinity 120, M alkalinity 160. If you see the relation, this is the, suppose 2p equal to 240, 2p equal to 240, is it equal to M? No. So then this is the P is now E equal to 120, M equal to 160, you got. So if you see the relation between phenolphthalein alkalinity, methyl orange alkalinity here, E equal to 120, the phenolphthalein M equal to 160, P is greater than. So if you see the relation between phenolphthalein alkalinity, you can write it as like this also. The phenolphthalein 2p, this is greater than
So here
M.
2p value how much here? P is the
So
120.
that means
So you can
2p
write it
value
as
is the
like this
240
also.
you are getting.
So 240 is it greater than 160 or
Is
not?
greater than
It
M.
is greater than. So here 2p
160.
value how much here?
So
P is
based upon this
120.
relation,
So 2p
we
value
can
is the
understand
240
that
you are getting.
where
So
the
240 is two
is
ions
it
that
greater
is
than
hydroxyl
160 or not?
ions.
Yes,
It
as
is
well
greater
as
than
carbonate ions
160.
are present.
So based upon
this
this relation, we can understand
water
that
sample.
where the
So how can you estimate
two
the
ions that is
hydroxyl
what is the
ions
formula?
as well
Here
as carbonate
2p
ions are
minus
present
M, it will give the
in this
hydroxyl
water, in
ions,
this water
whereas
sample.
the carbonate ions,
So how can you
into M
estimate
minus
the
P will give
hydroxyl
the
ion? What is the formula?
carbonate
Here
ions.
2p.
So based upon
minus
this formula,
M, it will
just
give
you
the
substitute the values 2p equal
hydroxyl
to
ions,
240, whereas the
that is
carbonate ions
240
2 into M minus P will give
minus
the M
carbonate
value is the 160.
ions.
So based
Thus you
upon
will
this
get the
formula, just you
80
substitute the values
ppm.
2p equal to
That will get
240.
the 80 ppm.
That is 240.
So that is the 80 ppm
Minus
is the
M value is the
hydroxyl
160.
amount.
In the
Thus
same
you will
manner, if
get
you
the
substitute the carbonate
80
values also 2
ppm.
into M minus
That
P,
will
where
get
the
the
M value
80
is the
ppm.
160.
So that is the 80
160
ppm
minus
is the
P value is the 120.
hydroxyl amount.
So in the same manner, if you substitute the carbonate values also 2 into M minus P, where the M value is the
160 minus 120, that will give the
160
2
minus
into
P
40,
value is the 120.
that is
So
equal to the 80.
here
That is
2
equal to
into
80 ppm. 160
so
minus
here
120,
the
that will give
carbonate
the
alkalinity
2 into
is 80
40,
ppm as well as
that is equal to
hydroxyl
the
also
80 ppm.
that is equal to
So
80
then ppm.
totally.
So here
160
the
ppm
carbonate
you are getting in the
alkalinity
same manner.
is
Total
80
alkalinity is
ppm
also
as well as
160.
you can understand that
Hydroxyl also
this is
80
about the ppm.
the problem.
So then and then
Totally
what are the chemical
160
reactions
ppm you are
also
getting
you
in
can
the same manner.
understand.
Total
Based
alkalinity
upon
is
this
also
160 you can understand that
here if you see the
this is about
reactions
the here OH
problem.
OH minus
And
ions
then
are present.
what are the chemical reactions
OH
also you can
minus plus
understand
H plus
based
ion
upon
gives
this
rise to H2O.
here if you see the reactions
that is the
here
one
OH
reaction.
OH minus ions
And
are
another
present.
ions is the carbonate ion is
OH
present.
minus
So
plus H
carbonate
plus
ion gives rise to
will react with the 1 mole of
H plus
H2O
ion to give the, that is the one reaction to give the, and another ion is the carbonate ion is present. So
after
carbonate ion
bicarbonate
will react with the 1 mole of H
so
plus ion
bicarbonate
to
is
give
also
the,
will react with 1 mole of
to give the
another mole of H
bicarbonate
plus ion.
So after
To give
bicarbonate
the
carbon dioxide plus
so bicarbonate is also will react
water
with 1 mole of.
So this is the, these are the reactions
Another mole of
involving
H
in
plus
the
ion.
chemical reaction of this to give the
Solution.
This is about the
Carbon dioxide
right.
plus
Thank you very much. Water. So
Subscribe
this
my
is the
channel.
these are the reactions involving in the chemical reaction of this solution. This is about the right. Thank you very much. Subscribe my channel.